PC builders are currently panic buying $700 motherboards because they are terrified of bottlenecking their new Ryzen 7 9800X3D. But look at the actual data. This chart compares the gaming frame rates of a budget $220 board directly against a flagship $700 board. For standard gaming setups, the output is identical. You don't gain a single frame for that extra cash. The real challenge is navigating an incredibly dense market. You need to provide enough power so your system doesn't choke, without setting fire to cache on features you will never use. Motherboards do not generate frames in a vacuum. Their entire value is relative to the specific GPU, memory, and storage you plug into them. The Ryzen 7 9800X3D complicates things because it is the first unlocked 3D V-cache chip AMD has ever released. That massive L3 cache means the processor spends less time waiting on data from your RAM and more time performing calculations. Because the chip is active for more of every clock cycle, it generates a higher and more sustained electrical demand, which puts a continuous, heavy load on your motherboard's power delivery system. If you drop this chip into a board with poor voltage regulation, heat builds up rapidly. During a 3-hour gaming session, the board will forcefully throttle the CPU's power to save itself, tanking your frame rates in the process. The same goes for memory training. A weak board struggles to maintain stability at DDR5 6000 to DDR5 8000 speeds. That is the exact frequency range where the 9800X3D performs best. You do not have to buy the most expensive option on the shelf, but a high-quality foundation is completely non-negotiable if you want sustained system stability and peak memory speeds. 9 different AM5 chipsets are technically compatible with this processor. We are going to ignore the noise and focus strictly on the optimal choices, the 800 series. This matrix shows the B850 and X870 chipsets. Both provide crucial PCIe 5.0 GPU support and robust power delivery. Stepping up to the X870E adds mandatory USB 4 and dedicated PCIe 5.0 lanes for multiple M.2 drives. USB 4 is where a lot of buyers get trapped. You pay a heavy premium for 40 gigabit per second transfer speeds. If you are plugging in external SSDs for video editing, that's great. If you only plug in a gaming mouse and a headset, that bandwidth is entirely wasted. You could drop down to legacy B650 or X670 boards to save a few dollars, but doing so means giving up out-of-the-box Wi-Fi 7 and settling for lower memory overclocking limits. For 95% of gamers who are not running massive external storage arrays, the B850 or standard X870 chipset hits the exact sweet spot of price and performance. Let's look at the absolute top of the market. The ASUS ROG Crosshair X870E Hero sits at roughly $700. This board has exactly one use case. It is built strictly for pushing flagship graphics cards like the RTX 5090 or the older RTX 4090 to their absolute limits. These top-tier flagship GPUs draw an absolutely massive amount of wattage. The Hero utilizes an 18+2+2 VRM configuration to handle extreme sustained power loads without a single dip in voltage. It keeps the 9800X3D completely stable under maximum stress. Right below that is the ASRock X870E Taichi at around $500. This is the sleeper choice for serious overclockers and those building heavy workstation storage arrays. This diagram shows the mechanical advantage of the Taichi's massive 27-phase VRM. Having more power stages distributes that thermal load across a wider physical area, actively preventing throttling during an all-day gaming or streaming marathon. You do make aesthetic trade-offs. The Taichi has a heavy industrial look with 0 RGB, and the BIOS interface is notably clunkier if you are used to ASUS or MSI menus. Both of these elite boards are phenomenal pieces of engineering, but buying a $700 motherboard to pair with a mid-range RTX 5070 Ti is a complete waste of hardware capability. For standard high-performance gaming, the MSI Mag X870 Tomahawk Wi-Fi sits right in the Goldilocks zone at roughly $290. It delivers rock-solid DDR5 8000 memory stability, PCIe 5.0 on the GPU, and the main M2 slot. The trade-off is right there in the specs. It only has one PCIe 5.0 M2 slot. If you edit high-res video and need an array of Gen 5 NVMe drives, you must look elsewhere. If you want to maximize your budget, the MSI Mag B850 Tomahawk Max Wi-Fi at $220 is the absolute value king. Buying this 14-phase board is a strategic move. If you have a strict $1,500 total budget, saving $70 on your motherboard gives you the cash to step up to a higher-tier graphics card. At this price, you lose USB 4 connectivity, and you sacrifice the highest-end memory overclocking ceilings. For pure gaming, it's a trade worth making. Finally, the Gigabyte X870E Aorus Elite Wi-Fi 7 at roughly $340 access the bridge between the budget boards and the Elite tier. This line chart shows its main software advantage in action. Gigabyte includes an X3D turbo mode that optimizes core usage, squeezing out a measurable gaming performance boost specifically in titles where the CPU is the limiting factor. The one minor compromise here is your networking. It relies on a 2.5 gigabit LAN port instead of the 5 gigabit standard found on competitor boards. Matching your motherboard choice to your networking and peripheral requirements ensures that every dollar spent is contributing to a higher FPS per dollar ratio. Selecting the right foundation for a 9800 X3D build is a matter of evaluating the specific components you are plugging into it. This flowchart maps your hardware paths. For an RTX 5090 with zero compromises, go to the ROG X870E Hero. For massive storage and overclocking, take the Taichi or Aorus Elite. For standard gaming, match your budget to the X870 or B850 Tomahawk. This scenario matching approach guarantees you get every frame the 9800 X3D can output without burning cash on features that don't impact your performance. Before you check out, let's talk about the lifespan of the hardware. The AM5 socket platform is staying put. AMD guarantees AM5 compatibility through at least the upcoming Zen 6 generation. The board you buy today has a long, viable life ahead of it. But do not fall into the trap of vastly overspeccing a motherboard right now to prepare for a hypothetical upgrade 5 years down the line. Buy for today, build for tomorrow. Purchase the board that meets your actual hardware needs right now, bake in exactly 1 generation of headroom, and put every remaining dollar directly into your graphics card.